Welcome, everyone. My name is Bethany, and I'm with the Plano Public Library. I want to thank you all for joining us today for STEAM Skills Coding and Circuits. Your microphones have been muted and videos turned off for this program. Please note that if you have any questions, you can type them into the chat. We will be monitoring the chat to assist you with any issues and bring questions to the presenter's attention. Any relevant links for the program today will be posted into the chat. I have the honor of introducing the Society of Women Engineers today. SWE motivates women to achieve full potential in careers as engineers and leaders, expanding the image of engineering profession as a positive force in improving the quality of life, and it also demonstrates the value of diversity. SWE will present the STEAM Skills 5-week course on coding and circuits. Today, the topic will be an introduction to Arduino and Tinkercad with Jenna, Sarah, and Nuha. Housekeeping reminders that we would like to share with everyone. Please note the program is being recorded and will be made available on the Plano Public Library YouTube page for later viewing. Soliciting business or selling merchandise during library virtual programs is prohibited. Please be considerate of our presenters and one another throughout the program. Any inappropriate behavior will result in your removal from today's program. I'd like to hand over the program to our presenters. Thank you.
Are we ready to go? All right, give me 1 second. You guys see this?
Yes.
All right, awesome. All right, guys, welcome to week 4, Intro to Arduino and Tinkercad. We're going to be transitioning today into our Arduino and Tinkercad unit. This is different from our previous units of C++ programming, where we did a lot of programming on the computer. We're now going to be moving into working with hardware, though virtually, and working on making circuits and then programming those circuits to do different things. So in this lesson, we'll be covering our introduction about what Tinkercad is, and Arduino and how to make an account, circuits in Tinkercad and how to use the design suite in Tinkercad, Arduino programming, how to program a component, and we'll be working a mini project at the end. All right, so to start, what is Tinkercad? Tinkercad is a free and intuitive web-based CAD program that anyone can use. It also has a circuit design and simulation feature we will be using today. Basically, Tinkercad allows you to work with different hardware programming stuff virtually. You can build circuits in it, you can use a mini computer called an Arduino, and you can also do different designs for different projects you want to work on. What is Arduino? Arduino is an open source electronic prototyping platform that also sells microcontrollers. Arduino language is C++ based. So we'll be using the knowledge from the previous weeks that we learned with C++ in this project as well. And Arduino is practically a mini computer where we used to program like a program on a computer that we have already. And Arduino is a little machine that you can program to do different stuff with components and circuits to cause them to do different things physically with hardware, though we will be doing this virtually, as I've said. And so we need to actually make an account on Tinkercad to be able to do this project. I believe Sarah will share a link with you guys. And basically speaking, you should be able to go onto this website and you can sign up with an email. And you'll be able to go to Join Now and create a personal account. So Sarah, are you sharing that right now? All right, guys. So if you guys want to go ahead and open that link, you should be able to make an account, or we can help you through that as well. If you have questions, put them in the chat, please. And Nuha, are you ready to take over?
Sure. So let me go ahead and share my screen. All right, can you all see my PowerPoint all right? So once you have made an account on Tinkercad and you log in, you're gonna be seeing this type of view, except this is a short snippet of what you're gonna see on your left side of your screen. There's gonna be 3D design, circuits, code blocks, all of which you can kind of experiment with within Tinkercad. But today this week and next week, we're gonna be working with the circuit part of Tinkercad and creating circuits within that. So we'll go ahead and go on to the next slide. Once you hit that circuits button and then do create new circuit, you're going to be faced with a window that has a toolbar up on the upper left. These are just your basic delete button for if you have different electrical components within your display, whether you want to delete them. This is undo and redo. And then moving on, you'll also have on the right side, kind of what we're going to be making a lot of use with today. There's going to be the code section where you'll actually be writing the code to your Arduino, which is a microcontroller that basically communicates with different electrical components such as LEDs is what we're going to be working with today. There's this play button that says start simulation, which will actually start the simulation of the circuit that you have created with whatever electrical components. Export, you can export JPEGs or PNGs of your CAD display, the architecture that you've created, and then you can also share direct links to different projects that you can send to your friends who can then create copies and then also play with that as well. There are basic components and features that we're going to be looking at. So one, there will be the component lists. If you click this drop down arrow, it's going to come up with various different categories of basic or resistors or LEDs that you can click, and then it will filter out those electrical devices that fit that category. There's going to be a component view, which shows and then following that, there's also going to be the actual code view, which when you click that, it'll open up the code section, the start simulation button, which we talked about before, and then the export and share. And so I wanted to go ahead and demo how this looks whenever you log in first onto Tinkercad, just because I know those were a lot of screenshots and a lot of words. So I'm gonna go ahead and stop sharing just for a second and then reshare my screen when you log on to Tinkercad. So when you have logged on to Tinkercad, this is what your screen is going to look like. As I mentioned before, you're just gonna hit that circuits, create a new circuit. It's gonna directly open up a new file that auto saves, and then you have those delete, redo, undo buttons, the code. Once you have a programmable component on your workspace, then it's going to generate a place for you to type in your code. So for example, we're going to be working with Arduino today. So you can just search that up in the search bar, click it, and drag it and drop it onto your display. You can also rename those different components. So let's say that you have multiple different resistors on your board and you want to have different names for all of them, then that's something that you can also do within Tinkercad. This is the code section where we're going to be working with. We're going to be working with blocks, then blocks and text, which will create the text for the blocks that you have created with your code. And then at the very end, once you've completed that display, you'll hit start simulation and it will do whatever you programmed your Arduino and circuit to do.
Nuha, can I interrupt you for 1 second?
Mm-hmm.
So Nuha was just doing an overview of everything. We're going to go into more detail when we start the project. A lot of people are asking, like, should we create a new project? Should we create a new design? Do we do a new circuit? What are we doing right now? But the answer is right now we're just kind of listening and waiting. And when we start the project, we'll give more detailed instruction.
Definitely. Right now, we're just kind of giving an overview of what Tinkercad is and its capabilities. At the very end, we're going to have a mini project. There's going to be a video instructable that we'll watch, and then I'll be sharing my screen and walking you step by step with how to create the circuit that we will be creating at the very end, once we've covered just the basic informational overview. So Jenna, I will go ahead and hand it off to you to discuss Arduino programming and the basic functions that we're going to be using in our mini project at the very end.
All right. So hopefully this part that I'm about to show you will be a little bit more familiar to you guys. This is our C++ programming that you guys should have had some experience with the last 3 weeks. And so when we work in Arduino and we build these circuits, we do actually have to program them to be able to do something. So it's a mixture of hardware and programming. And so the cool thing about Tinkercad is you guys actually will have the option to code in 2 different ways. The one way you could use is the block coding. What's cool about this is you don't have to actually know or understand how to code to do this. You basically are just putting instructions in order and telling the circuit to do something. So in this particular example, all we're doing is making an LED or like a miniature light bulb blank. And so on the left, you'll see right here, it says set built-in LED to high. That's basically saying turn this light or this LED on. It's saying wait 1 second, which is saying hold the light on for 1 second. And then it says set built-in LED to low. And basically it's saying turn the LED off, kind of like a switch. And then it's saying wait 1 second and keep it off. And what it's going to do the whole time is just literally keep blinking it up high for 1 second and then turn it off for 1 second. And that is the whole programming. Now, if you wanted to see the code version, this is about what it looks like over here. It might look a little weird and complicated, but don't worry, we won't be expecting you to fully understand this, and we'll be able to walk you through anything you need to do. But just giving a basic idea of how to do this. With Arduino and coding, there's always 2 of these little, like, I guess, functions you call them right here, these 2 little places where you put code. This first one just sets up what you're doing. So in this particular set of code, it's literally just saying, choose this place, this pin, this particular place on the Arduino to set up for output or to set up to use. All it's saying is use this part of the Arduino. And then within this part that's called loop, it's telling you what to do. And it's the same exact programming as over here, except for on the right side, it's saying the actual code. So it's called, digital write is the same thing as saying, tell the pin to turn on high or to turn on or to turn the LED on. The delay 1000 is for 1000 milliseconds. So it's the same thing as saying, wait 1 second or hold the LED on for 1 second. The digital write low is basically telling the LED to turn off again. And that's the same thing as it is on the left side. And then the delay 1000 is another, again, a delay for 1000 milliseconds, or it's saying to turn the LED off for 1 second. So all this program is doing is basically taking an LED or a miniature light bulb and saying turn on for 1 second and turn off for 1 second over and over again, which is actually what we're going to be doing today and what we will show you how to do. I know this might be a little confusing, but we are going to walk you step by step in just a couple seconds. So I'm going to go ahead and turn it over to Nuha, and hopefully we can help with any confusion everyone's feeling.
Nuha, you're currently muted.
Sorry about that. So as Jenna said, we're now going to be working into our mini project that we have today. It's going to be blinking an LED with Arduino within that Tinkercad website that we showed you. Before we do step into that though, I want to navigate to this first link, the Arduino and Tinkercad Basics. This is a 6-lesson, very short and sweet, that allows you to kind of experiment with pre-existing circuits that within Tinkercad and explains kind of how they work. So I'm going to go ahead and open the link on my end just so that you can see what you're supposed to be seeing. If you are already logged into your Tinkercad account, then it will just take you straight to the link. But if you need to log in, it might prompt you to do that as well. Once you have clicked that link, it's going to be called Project Zero, an introduction. So you are going to be learning about the Arduino platform, how to set up your kit, and how to interact with the circuit simulator. So we're going to just click that first lesson, the Welcome to Arduino. And give you guys an opportunity to kind of go at your own pace. We'll give you guys around 10 to 12 minutes just to go through the 6 lessons. It's okay if you don't complete it in its entirety, or if there's some areas where you're confused on and don't know what that means. We're happy to answer any questions that you may have. But we wanted to give you guys a visualization for what a complete project would look like and what the code would look like. This isn't the specific project that we're going to be working on today. This week, it will be a lot more simplified and kind of easy to adjust to, but we did want to give you guys some exposure to the various platforms, capabilities of Tinkercad and Arduino. So I'll go ahead and give you guys, again, just 10 minutes to just experiment with the link. If you guys have any questions, any technical difficulties, then make sure to let us know, and we're happy to work through that.
So right now we're exploring this link that Nuha shared with us. I put it in the chat. It's in there a couple of times. If anyone is still having trouble creating an account, you go to tinkercad.com and click on create a personal account. And you do need an email for that. So we don't have a class code to share with you. So I know that there's something that says students join here. So don't click that because we don't have a code for you. You'll be making a personal account, but you do need an email for that.
Here, do you want me to share my screen and just show them how to join the account real quick? I can do that real quick. I have it up.
Sure, I think that'd be helpful.
All right, give me 1 second. All right, can you guys see this? All right, so when you guys get in here, you guys should be, when you press on the link to tinkercad.com, this is what should show up. And so what you're gonna do is you're gonna go to join now, and then you're gonna create a personal account. And then I don't know if you guys have a Gmail or an Apple or your own email for your school. I would recommend using your email for your school, but you're gonna sign up with one of these 3 options. Now I already have an account, so I'm not actually gonna do this, but it's gonna ask you some questions. You're gonna put in your birth date, where you live. Okay, it doesn't want me to go forward. So I'm just gonna put in a random birth date. And then you're gonna put your email in, and then you're gonna create a password, and you're gonna create an account. And then it should let you in, and it should look like this when you come in. And then from there, When we get to it, you're going to go down to circuits and look in there. But for right now, we will then want you to go to this link that we also put in the chat, and you're going to run through these different simulations. So. And then it should load for you. It might take too long like this is. And you're going to go through this on the right, and you're going to press, and you're just going to go through this and read through it and play with the Arduino. Does that make sense? Awesome. And so we're going to go ahead and give you guys like 10 more minutes to hopefully work on that program and run through it. If you have any more questions, feel free to type them in the chat. And then Sarah, can you reshare both the links? It looks like some people are still missing them. Thank you.
Which two links, Jenna? I only had one link, the Arduino Tinkercad Basic so far.
Yeah, just
and the link, and the link to join an account.
Oh.
Yeah, and every time that you guys, so there's 6 total lessons within this project. The second you finish one lesson, it's going to prompt you to start the next lesson as well. So it's just that one link and you just have to work through it. And that's just to kind of get you familiar with this website and Arduino and how it works. And then we're going to be creating a circuit completely from scratch. And we will be sharing a video for you guys to watch, and then also a step-by-step demo where I'll be sharing my screen. If you guys have any other questions about creating a Tinkercad account or how to access the Project Zero that we're currently working through, then be sure to let us know, and we're happy to help you out with that.
One more thing that I want to say, a lot of you are asking questions like specifically about like some of the components that you're seeing and some of the functionality of the demo that you're going through right now. It's just an intro. There's no right or wrong. It's just for you to play around with a little bit. Once we start the project, we will start from scratch and we will explain a step at a time as to what you need to do. But right now it's not like right or wrong. You can just go through, do your best. It's just to get you familiar with what you're doing. Do y'all have any idea as to why it would say forbidden? My guess with it saying forbidden would be that maybe there's some kind of a filter or something on the computer or on the browser that you're using. Do y'all have any thoughts on that, Jenna?
No. I was gonna say my guess would be one of two things. A, if they didn't have an account and it required an account, then they need to just make the account. Or two, my guess is if there was like parental controls on it, stopping from using links in the chat or something. That would be my best guess. Do you guys have any ideas on the parent email problem that people are having? Sarah, Nuha?
I am not sure. So your username for your Tinkercad account should be the email that you signed up with. And the password is just something that you create.
All right.
So I would say this for right now. If you are having trouble getting into the demo link that we're all kind of exploring right now, you need to have an account for the mini project we're going to have later. So if you don't have an account at all, that has to be like the priority right now. So if you're having trouble just going to tinkercad.com and hitting join now, if you're having trouble with that, I would say like if you have a parent around, ask your parent, because I just don't really think that we can help with that. I don't see any way that we can get you around parental permission or anything like that. But I would say that that's the priority right now. So we'll try to help you however we can.
Okay. She's saying it's because if they're like underage or they're too young to like have a standalone email, then it requires a parent email.
So when you put in your birth date, if if you are underage, it will require that parent email, and then the parent will have to verify. I believe that's the process.
Okay. So I guess our best advice right now, if you guys have a parent near you, I would go ask them to help you verify their account. Otherwise, if not, I think it would still be worthwhile to watch us do the demo and show you how to do it, even if you can't access the account yourself.
And then these slides that we're working toward, like working through, and the links, various links within the PowerPoint are going to be sent out to all the participants. So if right now you're having difficulties creating a Tinkercad account and navigating the different links, then you are more than welcome to open up that PowerPoint later on when your parents are able to sit there and verify the account. Just because in order to create that circuit in that project, we do need that Tinkercad account to be made. But for now, we're going to be showing various videos, instructables, and demos that you guys can watch and then later implement once you're able to kind of get your account up and going.
And I also want to answer, there is a part of this that says we're going to program a real Arduino. Like obviously you don't have a real Arduino in front of you. So you can click through that. It has some pictures of a real Arduino and what it would look like. What we're doing today is all virtual. So it's telling you to download and to get ready for if you had that real Arduino in person. So I mean, if you do happen to have one, you can explore that later. But if you don't have one, you can just skip right over that part.
Nuha, do we want to go ahead and show them the mini project then? It looks like a good amount of people have finished, and then those who just can't get into the account can just watch for right now.
Perfect, yep. I'll go ahead and share my screen. And we're first going to watch just a short 5-minute video instructable on our project for today, which will be blinking an LED with Arduino within Tinkercad. So let me go ahead and share my screen. And
let's learn how to blink an LED using Arduino's digital output. If you're new to Arduino, this is a great place to start. You can follow along virtually using Tinkercad circuits. Then afterward, grab your Arduino Uno board and a USB cable to create a physical circuit. Take a look at this circuit in the work plane. Click Start Simulation to watch the LED blink. You can use the simulator at any time to test your circuits. The LED's legs are connected to 2 pins on the Arduino, ground and pin 13. The component between the LED and pin 13 is a resistor, which helps limit the current to prevent the LED from burning itself out. Without it, you get a warning that says the LED may burn out soon. It doesn't matter whether the resistor comes before or after the LED in the circuit or which way around it goes. The colored stripes indicate the resistor's value, and for this circuit, anywhere from 100 to 1,000 ohms will work great. Click once to connect a wire to a component or pin, and click again to connect the other end. The LED, unlike the resistor, is polarized, which means it only works when the legs are connected a certain way. The positive leg, called the anode, usually has a longer leg and is wired to power, in this case coming from your Arduino's output pin 13. The negative leg, called the cathode, with its shorter leg, connects to ground. Did you notice the small LED flashing on the board itself? This built-in LED is also connected to pin 13 and is meant to be used for testing purposes without the need to connect any external components. It even has its own tiny resistor soldered directly to the surface of the Arduino board. Let's look at the simple code controlling the blink by checking out the code blocks editor. The code starts out with 2 gray comment blocks, which are just notes for us humans to read. The first blue output block sets the built-in LED high, which is Arduino's way of describing on. This output command will activate a 5-volt signal to connect anything connected to the specified pin. Next up is a yellow command block that waits for 1 second. Simple enough. So the program will pause while the LED is on for 1 second. Next, after another comment, is a blue output block to set the LED back to low or off, followed by another second-long pause. Try customizing this code by changing the wait times and clicking Start Simulation. You can even add more output and wait blocks to create longer flashing patterns. In the text editor, you can see the Arduino code generated by the code blocks. All the extra symbols are part of Arduino's syntax, but don't get intimidated. It takes time to learn to write proper code from scratch. I'll break it down for you here, and you can always use the blocks for reference as you level up. This first section is a block comment followed by the code's setup, which helps set up things your program will need later. It runs once when the program starts up. Our Blink Sketches setup configures pin 13 as an output, which prepares the board to send signals to it rather than listen. The main body of the program is inside the loop. This part of the code will execute on repeat, so long as the board has power. The colored text following double slashes are also comments to help make the program easier to understand. The output command we're using is digital write, which is a function that sets a pin high or low, on or off. To pause the program, we'll use delay, which takes a number of milliseconds. 1 second is 1,000 milliseconds. Try it for yourself in Tinkercad Circuits. Grab this circuit anytime using the starter available in the Components panel. To program your physical Arduino Uno, copy the code from the window and paste it into an empty Arduino sketch, or click the Download Code button and open the resulting file using your Arduino software. Plug in your USB cable and select your board and port in the Tools menu, and upload the code and watch the LEDs flash with the custom blink you just created earlier. Now that you know how to blink an LED using Arduino's digital output, you're ready to try other Arduino exercises that utilize the digital write function. Try using a breadboard to add more LEDs and code to control them in the next lesson. Thanks for watching and learning how to blink an LED with Arduino and Tinkercad Circuits. Check out the rest of our huge collection of interactive beginner electronics tutorials
All right, so that was a short video that was basically detailing what exactly we're going to be working with in our mini project for today. So it's going to be one resistor, one LED, and then the Arduino, which we are using to basically talk to the LED and tell it when to turn on and when to turn off. The end snippet of that video did give a short instruction on how to implement this with physical components, like a real Arduino, a real LED, a real breadboard. That's not something that we're going to be working with today. As we mentioned before, this session will be entirely virtual, and we're simply going to be simulating that system within Tinkercad. There is a link to a readable instruction for this project, and I'll go ahead and have that link set in the chat. That way you guys can reference that while we're creating this project.
Sarah already sent it, so you were good.
Okay, perfect, awesome. All right, and as I kind of mentioned, we've already introduced the Arduino Uno, so now I kind of want to talk about resistors and LEDs, which are the main two electrical components that we're going to be working with today. So LEDs stand for light emitting diodes, turn on when they receive a certain amount of current or power. They are polarized, meaning they have a positive and negative side. The longer side is called the anode, is the positive side, and the shorter leg is known as the cathode and is also the negative side. So short is cathode and negative, long is positive and an anode. The positive side, the longer side, needs to be connected to the power, while—
Anuha, I'm sorry, are you meaning to be sharing your screen? We don't see your screen right now.
Oh, sorry, I forgot to pull up the PowerPoint slide. This is all that you should be seeing, just the resistor and the LED, which will look like what we're working with in the mini project. So nothing crazy. We just wanted to give you some visuals as I'm talking through the different components, which will definitely help. So you'll notice that longer side, as I was kind of talking about, is called the anode. It's the positive. The shorter side is the negative, and it's the cathode. This short side is connected to ground, and that's something that you'll see when we implement that with the Arduino, that shorter side is connected to the pin that is the ground pin, while this longer side is connected to that pin 13, where it's essentially sending power to that LED. A resistor is something that we put in between the anode and the Arduino, and that is in order to reduce the amount of current flowing in the circuit. It's also important because if too much current flows through your LED, it can burn out. And in Tinkercad, the software will warn us and tell us that, hey, this LED is going to burn out since you don't have a resistor. But in real life, you have to be careful about it because your LED can blow out. A resistor is not polarized, so it doesn't matter which way it's attached. For the LED, we needed it to be a certain way. Certain leg goes to this pin, certain leg goes to that pin. But for the resistor, you can orient it any way, and it will still reduce the amount of current flowing into that electrical component or that LED. There are different charts that you can find online that teach you how to read these values. There are usually 4 bands on a resistor. Band A is the first digit, band B is the second, band C is the multiplier, and band D is the tolerance. Tolerance is how much it can either go up or go down. So there's a base value that you know based off of bands A through C, and then that tolerance is kind of a different range that it can have a minimum or maximum resistance. Each color of the band means a different thing, means a different number. And that's all something that you can Google and experiment with. Tinkercad makes it really easy because all you need to do is type in the value that it wants, right? But in real life, when you're actually creating a circuit, you'll need to find the exact resistor with the exact colors around it that we're going to be using. And that is basically all that we're going to be talking about as far as detailing how these electrical components that we're going to be working with in our project work. Now we're actually going to go through and create this project within Tinkercad. So I'm going to stop sharing my screen just for a second, and then I'm going to share my screen with Tinkercad pulled up, and I'll walk you through. That way you guys can follow along. So once you have hit tinkercad.com, you'll see something like this. As we kind of mentioned, This is, again, I believe you have to have created an account and verified your email before you can see this. But once you go on to tinkercad.com and log in, this is what you will see. We don't want to create a 3D design today. So we're going to go down and hit circuits, and we're going to create a new circuit. And this will pull up a completely blank workspace. Once you're at this position, we're going to go down over to our components list, and you can scroll and see what they have. But since we already know what specific things we're going to be working with, we're going to be working with a resistor, an LED, and an Arduino. What we can do is we can just drag those onto our workspace right now, and then we'll connect them once we have the Arduino. So just search up Arduino and it will pull it up, click it, and drag it onto your workspace. As it was mentioned, we do need a specific resistor value. So Jenna, if you can just remind me, was it 220 ohms that we are doing in this project? It should say it on the slide.
220 ohms. Yep, I got it.
Perfect.
Hold up if you need anything.
Awesome. So we will just type in 220 right here. Make sure to click this and just hit ohms, right? So the same way you have meters, kilometers, centimeters, decimeters, your ohms, which is the unit for your resistor, can be really, really small, like a pico ohm, or a really, really big resistance, like a giga ohm. Right now, we're just going to be working with 220 ohms, and you'll notice when we enter that, it automatically changed those colors that we were originally talking about.
Sorry to interrupt real quick. Could you repeat all that just a little bit? Some people are asking if you go a little slower, just show how you did all that. I'm sorry about that, specifically with the resistor.
Perfect. Okay, so I'll go ahead and delete this resistor, right? So you don't need to make any changes to the Arduino and the LED. All I did was I searched up Arduino, clicked it, and then brought it to my workspace. Your LED, you'll just search up LED. Oop, that gets me my code. It should be the first one here, but in case it's not, if you just search up LED, then it's going to come up with the two different types. Make sure just to do the red LED for now. We can explore with the different LEDs later on once we've created this project successfully. So once again, just click it and drag it to your workspace. Now, the part that we are going to be tuning a little bit is our resistor. You're going to click it and come down over here. And once you put it on your workspace, it should generate this kind of text box that you can rename your resistor. But what we're changing is the actual resistance value. We want it to be 220 ohms. We type 220 manually, and then you're going to hit down on this drop menu and go simply to the ohm section. That is the symbol that you use for ohms. Ohms is the unit that you do to measure resistance. I was kind of explaining that for different circuits, you're going to have different resistance that you need to use. So based off of that, you might need to fiddle with this a little bit depending on which electrical components that you're using. But for us, we're only going to be using a 220 ohm. And once you manually enter that, your resistor will change color band. So originally it was red, black, brown. Now it's brown, red, red to reflect that 220 ohms is the resistance that we'll be using with. Now we have our three parts. Now we're actually going to be making the circuit and making it combine all together. The first thing that I'm going to do is drag this LED up here at the top. We don't need a breadboard simply because we're only going to be working with one LED. But as the video kind of mentioned, once you start introducing and incorporating more LEDs, we will have to bring in a breadboard. But for now, we're just going to be working with one LED. Just drag it closer to your Arduino. And if you hover over the two pins at the bottom, it's going to tell you which one's the cathode and which one's the anode. If you have the LED in front of you, it makes it really easy because one's longer than the other. But for Tinkercad Online, you can't really determine that. So it's really important that you hover over and make sure that you're putting the correct pin in the correct place. We're first going to take the cathode and ground it to this ground pin on your Arduino. On your Arduino, on the top side, if you have it oriented the way I do, there's going to be a GND. That is your ground pin. You're going to connect that to your cathode pin simply by clicking your mouse and that's going to generate a wire, and you're going to take it all the way down to where you can see it be ground. I like to change the color of my wire to be black whenever I'm grounding it. That way I know that that's ground. And you can also just move your LED just if you want to make it straighter. But that's just purely for aesthetic purposes. That doesn't really fiddle with the electrical working of the circuit. Now it comes time to connect your resistor to your anode, right? So we connected the cathode to ground. Our anode is going to power, but before we give it that voltage, that power, we need to send it through a resistor. We'll go ahead and just connect that like this. I'm gonna pull down my Arduino, that way there's space and you guys can physically see the wire going from terminal 1 of the resistor onto the breadboard, or excuse me, onto the Arduino. There's a whole bunch of pins that you can use in an Arduino, but for our purposes, we're just going to be using pin number 13. The only thing that changes if you change your pin on the Arduino to the LED is your actual code. You might remember that we pinned pin 13 as an output in our code. If you were to change it, then you would have to change that number in your code, but we'll just keep it for consistency's sake. We'll put it down to 13. And I'll go ahead and make this wire green just so that we know that that's going to power. We have our actual circuit. Now it comes time to actually writing the code. I want to take a little breather and a pause just in case there are any questions, anything that we want to run through, whether it's setting up the resistance value, dragging and dropping. Any questions, do let me know before I move on to the code section, because you got to make sure that this is solidified before we start writing code.
So there are just a couple questions that I think are kind of worth answering. So basically what we're doing is like this LED, you can think about it as a little light bulb. And what the Arduino is doing is it's going to output electricity into it. So we have an electrical flow, and you can kind of think about that as just like water. You know, we use water to refer to electricity a lot. And the resistor is pushing back that water a little bit so that the light doesn't get way too much electricity. Because what happens if a light gets way too much electricity? I mean, I'm sure you know, right? It's gonna explode. And actually, you can do that in Tinkercad. If you lower the resistance, you'll see a little mini explosion on your light. And then there's this other question about the pins. I knew how to explain that in the in one of the slides. Can we share the slide set? I think that someone was gonna share that link. Maybe I could do it, but I think Neha was gonna share that. But there is a slide that shows the difference between positive and negative pins. You can kind of think about it. You've seen that a lot, actually, if you just think of a battery. A battery has this plus side and a minus side, right? It's very similar to that. Sometimes, like for example, with this LED, if you switch the pins and you don't put them how Nuha has it here, it actually won't work, because we need there to be a certain direction that we go. Sometimes we can only go forwards, but we can't go backwards. Sometimes we can only go backwards and we can't go forwards. So you can think of that plus and minus as kind of like telling you where you can go. So in simple, very, very simple.
Definitely. Think about just the LED pins as like legs. It's got two legs. It's got a positive leg and a negative leg. Negative has to go to ground always. And sometimes when you forget to do that, you'll learn it the hard way. I definitely have blown a couple of electrical components because I forgot to ground something. So make sure that cathode, and you can tell which one is the cathode because Tinkercad tells you which one. If you hover over each of the legs, it'll tell you whether it's the cathode or the negative. Cathode is the negative one. So we're going to put that all the way to ground on the Arduino. And then our anode, we connect to a resistor, which is, as kind of Sarah explained, it controls how much electricity is going to that LED. 220 ohms is the resistance that is just right enough for it to give the amount of electricity for the LED to actually glow, but then still not too much to where it's going to blow the LED. Similarly, if, like Sarah was mentioning, if you lower the resistance, you'll make it so the higher the resistance, more electricity is going to that LED. So the higher you up your resistance, the more chance it is that it's going to blow up. Now, if you lower your resistance, past 2 or below 220 ohms, what's going to end up happening is the LED will light up, but the current won't be strong enough to where you'll actually see the LED glow. So that's why resistance is kind of important, because once you have that perfect value, you'll be able to get that LED working enough to where you can actually see the light, but also just little enough to where you're not completely blowing up the LED. So hopefully that kind of explains why resistance is important. It's the kind of the barrier, the filter between the electricity and the light bulb. Are there any more questions about just the 3 electrical components that we're working with before we move on to the actual coding part and telling it when to turn on and when to turn off?
Nuha, there's a really great question here about why are we connecting the LED to pin 13 and not to one of the voltages? So why aren't we connecting it to 5 volts? Why aren't we connecting it to 3.3 volts?
So the reason why we connect it to pin 13, and you could pin it to the 5 volts or the 3 volts, except if you do that, you won't be able to regulate it turning on and off, right? So when you send it to pin 13, in our code, we're gonna say, turn pin 13 on, and it's gonna pin that to the LED, and the LED will turn on. If you pin it to one of the 5 volts or the 3.3 volts, we're not able to kind of program our code for it to blink. It's just gonna be an LED that's on, and that stays on until you stop the power. So let me see if I can go ahead and show that. Like, let's say if I want to take this and I want to put it down to the 5 volts, let's just see what happens. I'll start my simulation and it's just going to stay on. So the LED works. It is a working circuit. It's doing what an LED is supposed to do. It's just going to turn on. Even if you move this 5 volts to the 3 volts, it will also, let me stop my simulation, and then I can move it to this voltage and it will still just stay on until I stop simulation, right? Which is essentially pulling the plug. By sending my LED to pin 13, I'm allowing myself to like kind of play around with the LED and have it turn on and stop, turn back on, turn off, just because we're gonna be programming that actual pin, whereas these pins just send a current through it continuously until you stop the power. All right, so now that we have our system made, we'll go ahead and start coding with this. So we're going to start working with the blocks just because that makes it easier, just because a lot of the stuff with Arduino is working with built-in functions like we had in C++ that are really important to know about. But for now, we just kind of want to experiment with the basic coding. And I think blocks do a really great job at just experimenting with the different demands that you can have for your Arduino. There's different types of functions or demands that you can tell your Arduino. There's an output, which is what we're going to be doing. You know whether something is an output because we want to see that LED turn on. So we know that we're going to be working with the output, the blue functions for actually turning the LED on and off. An input is something that we use in the case of, let's say we want to have a button that when we press it, then the LED turns on. You're going to need to read that button as an input, right? Think about it, if you're having to introduce something that's going to tell the LED what to do, that's going to be an input, whereas an output would just be simply turning on and off. Notations, these are just different comments. So especially when you get really familiar with programming in Arduino and C++, whatever it may be, these comments really help you because a lot of times you will go back and reference your old code that you've done for various other projects, and these comments make kind of explaining what's happening in your code really nice and clear. That way, when you go back to it, it's not just a whole bunch of letters and words, it's something that you can kind of make sense of and then kind of expand on that and just have that in your portfolio. These controls blocks are essentially going to be the wait. You can have it repeat 10 times. And each of these blocks have corresponding Arduino command codes that you'll be able to pull up with the blocks plus text. For our sake, we will first set the built-in LED to high. We're gonna wait 1 second, then we're gonna send it the built-in LED to low and then wait 1 second. That block is already there for me. So what I'm gonna try to do is I'm gonna create that from scratch in case that's not already generated when you hit the code button. So we'll hit code, we're going down to blocks. We're gonna first come up with an output just because we want that LED to light up. We are going to hit this first command of setting the built-in LED to high. Now, high essentially means, think of it like turning on. So we're setting the LED to on. And then we're gonna wait 1 second. You're gonna hit the controls and attach that. Then we are going to set the LED to low, turning it off. And then we can wait 1 more second. And you can also play around with if you want it to be 1 millisecond, which will be really, really fast, kind of hard to see. You can make it 2 seconds, you can make it 2 seconds. So let's just have that as 2 seconds. Then this is the blocks to text, which is the programming that we are going to be doing, or that the Arduino is actually going to be set. That way it knows what to do. As Jenna kind of touched on before, your Arduino code has 2 main, think of it like umbrellas. You have one umbrella, which is your void setup, and you have one umbrella, which is your loop. Your void setup is essentially where you're setting things to outputs. So for example, for our case, we had it pin 13. Let's say you wanted it to be pin 11. You could change that wiring to go to pin 11, but you'd have to make sure your code also is telling the Arduino, hey, I want pin 11 to be an output. If you have multiple LEDs, multiple buttons, multiple things, for each one of them, you're going to need to have a different pin mode command, pin mode like line. And depending on if it's an input or output, that's what you're essentially doing. This is the very beginning part of the code. It's essentially saying, hey, Arduino, this is what we're working with. For our purposes, we're just working with pin 13. Then you have your second umbrella, which is your loop. You're gonna have 4 main commands, which is essentially writing digital write, which is, think of it like a sending message. Like you're sending 13, pin 13 to be high. I don't know why there's a bubble over there blocking it. Let me just delete that. So digital write, we're writing pin 13 to be high. To be on, we're gonna delay 2000. So the delay function works in milliseconds. So let's say you want 2 seconds, you're actually gonna have to do 2000 milliseconds, and you can change this number and it's gonna change the delay between when the LED turns on and when it turns back off. Then after we've had that delay, we're saying, okay, now I want you to tell pin 13 where we have that LED as low, and then delay for another 2000 milliseconds before we loop back and repeat it. So this umbrella is called the loop because everything inside just keeps happening again and again and again. It repeats, just like the loops you've been working with, the for loop, the while loop. And you can implement while and for loops within this, but for our purposes, we're just having it turn on and off. Are there any questions about the code and the different functions? So there's 3 main functions. Pin mode, which is saying, Arduino, I want you to note that on pin 13, there's an output. You don't have to specify that it's an LED, but sometimes in my code, I like to write a comment that says LED 1, LED 2. That way I know, okay, pin 13 is that output.
Nuha, we have, oh, can I interrupt you?
No, yes.
Yeah, we have this really great question. I think it's great, especially since they've been looking at code. Why aren't we ending the code? Why is there no end? Why is there no stop? What if we wanted it to only repeat 5 times? Can you talk a little bit about that?
Yeah, so we can implement a way for it to only run 5 times by using kind of a counter and a for loop and incrementing that. For the purposes of why this doesn't end in our situation is kind of in the sense to where we're powering the Arduino to do something, and until that Arduino stops getting that power, then it's going to keep doing that unless you've specified in your code that, hey, I want it to only loop 5 times, which is something that we can definitely work with. I don't know why it's not letting me edit the code right now. So later on, I can definitely show you how we would implement it to only run, for example, 5 times.
I jump in here too. A lot of times when we use Arduino, it's used in like physical hardware. Like, so I'm a biomedical engineering major. We use them in a lot of biomedical engineering devices. We don't necessarily require them to end the loop. That's why Arduino is set up without a natural end of the loop. You have to write the code yourself to make it end. And the reason being, for instance, is like a common thing we use it is in a pacemaker, which helps control the amount that your heart beats, right? Well, if we had the loop end, that would stop someone's heart in real life, and we wouldn't want that to happen. And so sometimes these like programmable microcontrollers are made so that they just consistently work in loop, because in practical use, we need to use them in ways where they don't ever stop.
Definitely, yeah. So every invention, every gadget, everything that you're gonna make is different and has its own different demands. For our sake, we don't really need it to end, so we're not gonna have that. And for a lot of kind of like the pacemaker, which Jenna mentioned, you don't really want that just because it does have like repercussions, because you want the device to constantly be going. If you do want it to stop, then there's definitely ways to do that, but you're gonna have to explicitly explain that in your code. For your Arduino, you're gonna need it to say, okay, stop at this point, if that makes sense. All right, so we have our blocks, we have our text, we have our code, we have our setup. Let's go ahead and start the simulation. So it should turn on. Have a delay of 2 seconds in between it turning on and turning off. So I want to see if I can go ahead and write a code for, let's say, for it's only lighting up 5 times, right? So similar to how we would do it, our code right now is just basically telling the LED to turn on and off with a delay of 2 seconds until I stop the simulation or until I pull the plug on this Arduino, right? Let's say we have a counter that is equal to 0. And for counter is less than or equal to 5. And then we can have the digital write 13 high, where we're telling you, okay, turn on. We're gonna have it delay 2000. We will digital write 13 low. And this is stuff that you can manually do too, versus working with the blocks that we have. And then I'm going to go ahead and delete all of that. Delay 2000. Okay, all right, hold on. Let's give it.
I think you need braces.
Am I missing braces?
Yeah.
Yeah. And also, I think after the lines, you need some semicolons, like 14.
Yeah, and the delay 2000, the digital write and delay 2000.
I am so sorry. I've been working with Python and not C++, where you don't need brackets and semicolons. So I do apologize. I'm a little bit rusty on my C++. Okay, what's the issue now?
Totally good. Let's see. Oh, double equal sign for counter. For counter, you have an assignment operator. Oh wait, maybe not.
So after the second counter is less than or equal to 5, it should be a semicolon.
Oh, yep.
And where you have counter is less than or equal to 5, you need a space between counter and the symbol.
No, it's the syntax between these languages, so hard to remember everything.
Yes, thank you. I am very rusty on my C++. I've just been doing Python, so I'd like to apologize. Oh no, what's going on? It was not declared in the scope, but I did declare it.
A counter. Do you have an int variable, or do you want it to be a you don't have a? Yeah.
Fantastic. All right. Now it should work.
Oh my goodness. Here, I'll try rerunning the code on my end. We'll see if.
Yeah, I don't know why it is.
Delay 2000. Does it have like a compiler that could say like what it wants?
Don't think so. It's not giving me any errors, but it's not blinking on and off like I told, because I have high over here. That's supposed to be low. Right.
I guess it's in the mood to be moody, I guess. Let's see.
And I'm just very rusty.
You're all good.
Okay. So so the way I programmed it, the LED should only turn on 5 times. So this is the 3rd time. This is the 4th time. This is the 5th time. And then it just stays off. No, it does not stay off.
It's being moody,
Well,
I guess.
the thing is, I think it's just gonna keep looping through, right? So as soon as it does 5, then the counter goes back to 0, and then it does a for loop again. So.
Oh, right. So what you actually need is to put the digital write high, I guess, in a loop, but then once you need to have a way to cancel out the counter so that it's not less than.
I mean, it's gonna keep repeating because we have the counter being set to 0. So actually to end these things, I don't know exactly what the command is, but there's a command you can add at the end of the loop. But that might be I'll try to look for it.
So if anyone's still having trouble just blinking their light, whenever you use Tinkercad and you drag and drop the Arduino, the code that we started with will already be there. You don't have to write it. So if you drag and drop a brand new Arduino and you go and you click code, you'll see the blinking code that we started with that is on that repeating loop, right? And Nuha's just trying to answer like kind of some of these questions about like, how can we get it to run like a certain number of times? How can we stop it? How can we do things like that to answer some of these great questions that we're getting? But you know, we don't get really caught up on this part. Just like if you got it to blink, why don't you give us a shout out if you got it to blink? And that was our goal today. So it's great if you got that far.
And just to answer that question, which maybe you can experiment, but for there's an exit 0 method that you use to end an Arduino loop. So to answer your question on how can I get it to stop without stopping my simulation, that's the line of code that you can incorporate and kind of play around with. But for our sake, we're just trying to get the LED to blink, and it has blinked. So let's go ahead and see if we can incorporate more LEDs within our system. So for this, I'm going to go ahead and add a breadboard just so that we can have all our LEDs on one board. Let's go ahead and pull this to be up here. I'm going to zoom out so you can see all of that. And the same way as wiring, you're just going to hit those 2 buttons or those 2 holes wherever you're going to put it. So in our case, we'll go ahead and delete the wiring that we have, and we'll just move our breadboard or that LED onto the breadboard. I'm going to move this resistor down over here. And let's say we want to have 3 different LEDs. We can keep adding the LED. We'll have another one and put that on our breadboard. We'll add a 3rd one and have that on our breadboard. And then similarly, just as we did, we are going to go ahead and have this same resistor on each LED on the anode pin. So I just am Control-C, Control-V to make copies of those 3 resistors. These 2 additional resistors should already have the 220 ohms that we manually entered for that first resistor. And we're going to go ahead and do the same thing where we connect it to our anode pin. I'm going to zoom in just so that you guys can see that a little bit better. But when you're working with a breadboard, it's the same similar kind of line of thought and reasoning is we're just going to connect it down to each of those pins or each of those anodes. And we're going to put that there. There should be a 3rd one, and we'll go ahead and put that there. And then just as we did before, I am going to connect that to pins 13, to pin 12, and to pin 11. All right. And then to connect your ground and put your power into this breadboard, what you're going to do is connect this ground pin to the negative rail on the breadboard. So we have 2 rails, a negative and a positive. The negative is ground and the positive is the voltage. And they're on both sides. And it's important, especially when you have a breadboard with a lot of components, that you connect the negative to the negative and the positive rail to the other positive rail. And I'm just going to be changing this. So again, this is just connecting my negative rail at the top to my negative rail at the bottom. And I'm going to change that to black just because for ground, I have that. And then for my positive rails, I like to have my wires as red. And then we sent the ground pin kind of to this negative rail, which also sends it to this negative rail. And now all we're doing is we're going to be connecting these cathodes, our negatives, to that negative rail where that ground pin is also. They're all going to share that same row of being a negative. And we'll go ahead and change these wires to be black just so that it makes it really easy.
Anuha, can you slow down a little bit? We're getting some requests to slow down. While we're slowing down, can you talk a little bit about the breadboard connections and how it's connected across?
Mm-hmm. Yeah, so the breadboard is just a rectangular thing that kind of looks like a sponge when you have it in real life. And there's kind of a left side and a right side. Right now, that left side and right side are kind of top and bottom. And so let's say you have the LED, this LED up here. In order for my power from my Arduino, which I would have it go from the 5 voltage and have it go all the way to the positive railing, I would need to have a wire connecting those two ends. And that's why I have this negative ground from the Arduino going to the negative rail of the breadboard. And I just went ahead just for good measure, but you don't really need this, these two wires because all our LEDs are on the bottom half, if you will. We would make these two connections of this positive rail going to this positive rail and this negative rail going to this negative rail. If you had LEDs up here that you wanted to make sure that, hey, I have to make sure that they're getting their power from my 5-volt pin of my Arduino onto the positive rail, and then it also gets my ground. And so we'll basically have each of the cathodes go to the negative rail. And we have the resistors from the anode in between the anode and the pin that we're going to be programming to an output. And if we start the simulation right now, my code only is telling this light bulb to turn on, but just to verify that we have all the correct wiring, I'm going to start the simulation and it does turn on. There is, so we know that our wiring is correct. You just have to make sure that you send this 5-volt power in the Arduino to the positive rail. And that's basically sending that current, that voltage, that electricity onto the board to then send it to each of those LEDs with the resistors and with. So it's a lot of wiring, but it's kind of the same wiring for each of the LEDs. It doesn't change for each of the LEDs. The only thing that changes is which pin it goes to. You can't have 2 LEDs going to 1 pin because then it's kind of the same thing as declaring the same value to 2 different variables or reassigning that. So make sure to have your LED to 3 different outputs, pins on your LED, and make sure that you ground your pin instead of to the cathode directly. We could just put each of the cathodes to this ground and send this 5 volts, wiring it to each one of those LEDs like we did before. But the reason why I have it where I'm using the positive and the negative rails is simply because I only have to connect things to the rails and have to connect the rails to one thing. I'm not having to make multiple connections to multiple various things directly. I'm utilizing these 2 rails. That way my wires are nice and clean and not very cluttered, but I could theoretically send this pin directly to this ground, send this pin directly to this ground, send this pin directly to this ground, and my circuit would still work, but partly for aesthetics and just it's a good habit to make sure that you're using the positive rails just because it helps when you have a lot of things on your breadboard, keeping track of what is going where. We know that each of these are going to the negative rail, which that negative rail is going to ground. And we have the positive from the Arduino going down to the 5 volts. And we can add in those second LEDs, which were on pin 12 and pin 11. So we have pin mode 12 as an output. That is setting it up, that's saying, hey, Arduino, you have something at pin 12 that you need to remember and that you need a note of. We'll have 11B.
After you finish this code, can you zoom out? Some of them want to like see the full view so they can try and copy it. Yes. So go ahead and finish the code, but if you after that, if you could zoom out and let them see the whole thing, that would be great.
Definitely. And we can go ahead and write that same digital write command for pin 12 and pin 11. Make sure to remember your semicolons, especially in C++, otherwise your code will not work, like how it was giving me issues earlier. So make sure that you have your parentheses and your semicolons. So we're telling each pin to be on, right, to be high, 11, 12, and 13, which are the same pins for each of these LEDs. And then we're gonna have it be digital write 12 as being low, telling, hey, turn pin 12 off. Digital write. And I'll go ahead and run this real quick, but then I'll also zoom out and maybe also rewire it for those that need help with that. So let's go ahead and, yeah, so as you can see, they're turning on and off at the same time because that's what I told the program to do. I'm gonna go ahead and stop my simulation and I'm gonna rewire it, just starting from scratch, since I think I went a little bit too fast. So I'll start off with my resistors and LEDs already on my breadboard, and then we'll rerun the wiring of wiring the breadboard to my Arduino. I'll zoom in so we can see it a little bit better. But in a breadboard, you have these holes that you essentially put your pins in, those legs. So the cathode leg is in this one and the anode is in this one. And that's why we connect that resistor directly to that anode. And you can move it to the next row, but that's not connecting it to that anode, right? So we have to make sure that it's on that terminal 2 of that resistor is on that anode for each of these LEDs. Now, our next step would be the process of grounding each of our LEDs. And in our previous setup, all we did was we pinned this directly anode, this cathode directly onto the ground pin of the Arduino. But since we have multiple LEDs, I'm gonna be utilizing the negative rail of my breadboard. And I'm just gonna put each of them to the negative rail. And in order to ensure that this negative rail, telling it to actually be ground, I'm going to be connecting my ground pin to my negative rail, right? We're pinning each of these LEDs to ground directly because that ground pin goes to that negative rail that each of those cathodes are also going to, that same negative rail. We'll go ahead and turn all these black just for aesthetic purposes. I like to have my wires that are ground be black. And now comes the time for sending each of these LEDs onto a pin. So we'll send this one to pin 13. I'm going to change this color to be green. We'll go ahead and connect this resistor, which is connected to that LED, and we'll have each of that there. So now we have it powered to each of these pins, but we don't actually have power going to that breadboard. We have ground going to that breadboard, right? We had this ground pin going into the breadboard. So the breadboard has a ground that we're sending all the cathodes to, but we have to give it some sort of power. And that's when we're going to be utilizing either the 3.3 voltage or the 5 voltage. For our purposes, you can use either and it's still gonna work. Depending on the tolerances and the resistance, you might be better using one or the other, but you can use any of these voltages. And we are going to be sending this to the positive rail. So we had a negative rail and now we have a positive rail. And I'm gonna go ahead and have that be red. And now we have actually powered our Arduino to that breadboard. Now that breadboard has electricity going through it. Without it, it wouldn't have the electricity because we're connecting the pins to the negative rails, right? So you have to tell, or the positive and the negative rails. Negative rail goes to ground. Positive rail goes directly to that voltage source from the Arduino. That's giving it the power to turn on and off the LEDs that are on the breadboard. So hopefully that was a better walkthrough and a more slowed down. I am happy to zoom in. That way you guys can see better. I'm trying to, and then this wire is just immediately going down to the 5-volt pin. You can also do it to the 3-volt pin, whichever one you want. It's gonna work in either case for our project here. Are there any more questions about the wiring? And
I think we were okay to continue.
perfect. We'll start that simulation. And remember, we have to make sure we make an edit to the code. We have the LEDs on the breadboard. The breadboard knows that there's LEDs, but we got to make sure the Arduino knows too, right? So that's why we have to have these 2 additional lines setting each LED, the new ones, 12 and 11 to outputs. We're also going to need to add 2 more lines of code telling it to turn on. That digital write 12 high tells 12 to be on, send a voltage to 12 pin, make sure it's high so the LED is on, is essentially what that line of code is saying. That same thing for pin number 11, which is our last LED. We'll have that delay 0. So all a delay of 2 seconds, all of them will turn on at the same time. Then there's going to be a delay, and then they're all going to turn off at the same time. The only thing that's changing in between each of these is the pin number. And that's to make sure that your Arduino knows that we have 3 distinct LEDs that we're working with, and we got to turn all of them on and we have to turn all of them off. And if we start the simulation, they will all turn on and they will have a delay of 2 seconds in between them turning on and turning off. Let's say we want it to be a 500 milliseconds, so half a second. All it's going to do is blink the LED, blink, turn on and off. All it's going to do that at a quicker pace. So it's just going to be on, off much more quicker. And we can even make this a lot smaller. We can do it for half of that. So 1/4 of a second would be 250 milliseconds. And if you start that simulation, it's going to be on and off, blinking much more quicker than it was originally. So you can play around with those numbers. And remember that this number that you put in is the amount of milliseconds, not the amount of seconds. If we were to do something really small, like 1 millisecond, it would be really quick to where I'm not even sure if it would be able to display how quick it's turning on and off. It might just look like it's turning on. Yeah, so when the delay is small enough, right? So this is like 1/1000th of a second. It's so fast that you can't see how fast that it's actually going, but it is actually turning on and off. Just the delay is so small that it's not able to register, and the LED isn't able to like show that, if that makes sense. But 250 milliseconds is a good number to where it turns on and off and blinks at a fast enough pace. Whereas for 2 seconds, it's just going to be 2 seconds or 2000 milliseconds. There is a different LED that you can work with. This is a red, green, and blue LED, and you are more than welcome to play with this later on, but it has that same, it has a cathode, right, which is our negative pin. That's what we're sending to the negative rail, to the ground, is our cathode. And then it has 3 additional pins, red, blue, and green. And think of it like this pin, this LED has 3 anodes and 1 cathode, right? So what you'll need to do is, depending on which color you want, is the color that you will pin, pin that leg to, right? So let's say if we wanted to have this LED, I'll go ahead and delete this one LED. Okay, and we'll put this LED right here. And let's say I'm having it go to the green leg. I have to make sure my cathode goes to ground, just like I did before. And if I start the simulation, there, it's going to be turning green, but you'll notice that the resistance for this specific LED is too little. And so that's why I was having that little explosion. So the red, green, and blue LED needs to be at a higher resistance for it to not completely blow out. But our 220 ohm works just fine for this simple red LED.
Nuha, can you show the code again so
Yes.
that everybody can kind of check their code against it?
And I did want to suggest, do we want to maybe, after we let them look at the code, go ahead and let the library do their presentation, and then after that move into questions? And so if they want to see anything special, we can do it then, and we can also answer any questions with things people are having trouble with.
Yep.
I also have like a couple of real components here that I can show. This is an Arduino from Texas Instruments. So you can see that it looks kind of different from the one we're working with here, but you can see here the pins. It's basically the same thing. And then I have another one here that's also the same thing. It's a microcontroller. And you can see these are the pins that we've been working with here. And I have some real LEDs. They're not hooked up, but here's a red one. And here's another one. This one is either blue or green. I don't know, I'd have to plug it in. And I actually have a breadboard all kind of set up to do something else from school. So it looks like this. So this is basically what you're working with online right now.
Yeah, for a lot of the projects that we do, and just in school, a lot of times our professors will have us make the system on Tinkercad and then have it working and then actually implement it with hardware that they've given us. So for this past semester, there were various different circuits that I had to first make within Tinkercad, and then you would basically implement the same exact thing into real hardware components that look a lot like what Sarah just showed you.
All right. Does the library, someone from the library want to go ahead and do their presentation now? And then afterwards we can take any more questions people have.
Sure, sounds like a great idea.
All
Let me
right.
go ahead. Share my screen. All right, can everyone see that? Yeah.
Yes, you are good.
So thanks so much for joining us today. I'd really like to give a special thank you to our presenters for providing this really amazing program. And as we wrap up, I'd like to share just a few library resources for you. So for more hands-on STEAM activities, the Plano Public Library offers STEAM kits for all ages. STEAM kits include learning components for science, technology, engineering, arts, and math to support STEAM-based learning, just like this coding program today. Our teen STEAM kits focus on technology and problem solving. You can check out kits like the Teen Kano Computer Kit, Teen Littlebits Arduino Kit, and the Teen Raspberry Pi 3 Kit. To see more kits, check out the Plano Public Library catalog. The library also offers 3D printing services at Davis Library, Harrington Library, and Parr Library. You can use 3D design software programs like Tinkercad to design your own 3D models. You can submit your design as an .stl file on a USB flash drive, and then the Plano Public Library staff will print your creation. For more information on how to submit your 3D design, pricing, and 3D printing classes, again, refer to the planolibrary.org. So your Plano Public Library card grants you access to thousands of courses on LinkedIn Learning. You can expand your coding knowledge by checking out courses on Arduino, Tinkercad, C++ programming, and more. Access LinkedIn Learning on the Plano Public Library website under Research and Learn. Please note that Frisco residents do not have access to this service. So be sure to stay up to date with the Plano Library by following our Facebook page and checking out our blog at planolibrarylearns.org. You can find out recordings of past programs and other materials about how to take advantage of everything that the Plano Library has to offer. Please complete our program survey, which should pop up following this program. We really value your feedback. And thanks again for joining us. I'll turn it back to the SWE so they can answer your questions.
All right.
Neha, are you going to provide the link to the slides for our participants?
Yes, I'll email it to the librarians and they can have it on their website.
And so if anyone, you guys are good to leave, you're done. If you have any questions, we will stay after and answer them for you, or we can do some more examples for you. You guys can let us know in the chat.
So there's this question, how do Arduinos and breadboards apply to real life? So as Nuha mentioned, we use them at school to learn about electricity and learn about components, learn about computers, things like that. But you can use it for all sorts of projects. Like you could use it to automatically water your plants. You could use it to program all sorts of things. If you just Google Arduino projects or Arduino DIY projects or Arduino home projects, you can see all the kinds of things that you can program in Arduino to do. And yeah, you can basically automate anything with the Arduino. So it's pretty cool.
They're also commonly used just in different devices. Like I kind of mentioned earlier, it was a biomedical engineering device. So they're super important to my major and my career because they're used in a lot of the medical devices you see out in the world, but they can also be used in other non-medical uses as well. Similarly, your phone kind of runs on a similar idea, not necessarily an Arduino, but on the miniature computer that you use to program hardware. And so we use it in a lot of different ways in industry and real life.
And to kind of go off of that, for breadboards, so typically breadboards are used to prototype projects. So if you're a student, you'll keep creating different circuits. So with a breadboard, it's easy to plug in the components and make sure that you can get your circuit to work, and then take those out and then reuse that same breadboard and those same pin connections for a different project.
And then people have been asking about where to find the previous class recordings and the Q&As in the chat. Does anyone want to tell them where that is?
The recordings will be available on the library's YouTube channel. Just check back periodically for when they are, they need to go through some editing, but that's where they'll be eventually. So I'll put the link to the library's YouTube channel back in the chat.
I think there is one question asking how long are the sessions typically? So we have a blocked-in window from 3 p.m. to 5 p.m., but we usually finish within an hour and a half. So you're looking at anywhere from an hour to 2 hour long sessions that begin at 3 o'clock here on this Zoom meeting. Yes, if you have no other questions or concerns, then you are more than free to go on and head out. The next class will be next week on Wednesday, same time, 3 to 5 p.m. And we're going to be doing some more different projects with Arduino and breadboards. And that will be the last session of our STEAM coding and circuits program that we've had with the Haggard Public Library.
Okay, I think if no one has any more questions, yes, you don't have to attend next week. There will be a recording on the library's YouTube channel at a later date, so you can search for it. And if there are no more questions, we will say goodbye.